Hello, my dear fourth graders. My name is Caroline Smith. Today we are doing Unit 3, Lesson 10, which should be on page 125 of your book. And you probably want to grab your whiteboard and marker because, you want to have enough space to do your work. So, in this lesson, we're analyzing some different word problems. These are one-step word problems, so we can expect that there's one step in them, but sometimes the word problems you encounter could have more than that, so just keep that in mind. And there's a fun little winter carnival theme to them. So let's go ahead and get started. And we're taking the time to analyze what we're doing here. Why are we choosing one operation over another, right? Okay. Number 1, 2 students from each 4th and 5th grade class were on the planning committee. If Jackson School has 14 4th and 5th grade classes in all, how many students planned the carnival? And so I should have read up here before. The 4th and 5th grade classes at Jackson Elementary are held a Just for Fun winter carnival. All students in the school were invited. So we have some numbers here. We have 2 students from each class on the committee. There's 4th and 5th, but I think that's just naming what the group is. I don't think we need to have that's not part of the question really. And there are 14 classes in all. So what kind of equation do you think that would go along with? You can go ahead. I'm going to say it's 2 times 14. Why do you think it's 2 times 14? Well, there's 14 classes, right? And there's 2 kids from each class. So it's 2 from class A, 2 from class B, 2 from class C, all the way till you have 14 classes. So that is 14 groups of 2. Now let's go ahead and set up on our whiteboard our little 14 times 2. 2 times 4 is 8. 2 times 10, I should say, is 20. Add those up, and you have 28. Right? So, then we'll say 2 times 4 is 28 students. Another way that could be written is 2 times 14 equals S, and then S equals 28 students. We want to become comfortable using those letters in our math, right? Because 4th graders, right? Okay, number 2, to advertise the carnival, students decorated 4 hallway bulletin boards. They started with 2,025 pieces of colored paper. When they finished, they had 9 pieces left. How many pieces of paper did they use? So, we have some numbers here. We have the 4 hallway bulletin boards. We have this 2,025 pieces of paper, and we have 9 pieces left. Now, in order to solve a question, we have to know what the question is. So the question is asking how many pieces of paper did they use? It's not asking how many pieces of paper on each hallway or anything like that. So you might need to take a step back, for what we've been doing in the past couple weeks. Back to the earlier grades. You have a total, you have one partner, and you're looking for the other partner. You have basically a little math mountain, right? You have your 2025, 9, and this is the amount that they use. Well, how do we find that missing amount? We subtract, right? Minus 9. 5 minus 9 is not going to work, so we have to ungroup. We look over to our tens place. We'll leave one of those 10s there. The other 10 joins what's in the ones place. So now we have 15 take away 9, which is 6. 10 take away nothing is 10. 0, 2. So what they used was 2,016 pieces of paper. And the equation that we'll write for that is 2,025 minus 9 equals, let's use P. P equals 2016 pieces. All right. Okay. If you're feeling confident, go ahead and do 3 and 4 on your own. If you'd like to stay with me, though, you're welcome to. But after you do number 4, if you're on your own, hit play so you can correct it with me, okay? All right. The parents ordered pizzas to serve at the carnival. That's nice. Each pizza was cut into 8 slices. How many pizzas had to be ordered so that 1,319 people could each have 1 slice? Okay, so let's see. We're looking for the number of pizzas, and each pizza has 8 slices, right? So P times what equals 1319, right? 1,319, so they could each have 1 slice. I'm glad they don't all need 2 slices. So then how do we find out what P is? Well, we're gonna have to do 1,319 divided by 8 equals P, right? Now I'm suspecting that we're gonna have a remainder, right? If we have a remainder in this situation, what does that mean in terms of numbers of pizzas that need to be ordered? Say it's like, well, we'll come to that in a minute. We'll think about that. Okay, let's go ahead and divide this. So 8 over here, 1,319 there. So how many times can 8 go into 1? Not really. How many times can 8 go into 13? Once. 8 times 1 is 8. Subtract. Difference is 5. Bring that 1 down. 8 times what gets close to but not over 51? Well, I know 8 times 7 is 56, so 8 times 6 is 48. Find that difference there. Okay. And then 39. Okay, 8 times what gets you close to but not over 39? 8 times 4 is 32. Find that difference, it's 7. The remainder 7. Let's write that down and then we'll think about what that means in terms of how many pizzas need to be purchased. Okay, so we have 1,319 divided by 8 equals P. P equals 164, remainder 7. Now this means that there will be 7 people, I think, short of getting a slice of pizza, right? So just to be on the safe side, we should go up and get 165 pizzas. Okay. Number 4. There were 825 students signed up to run in timed races. If exactly 6 students ran in each race, how many races were there? Okay. So let's go ahead. And we have the total number of 825. And they have been divvied up into races, right? So we'll have 825 divided by 6 to figure out the number of races, right? Because it's students times races equal total students, or like racers times races. Yeah, okay. So how many times can 6 go into 8? Once, right? And 1 times 6 is 6. Subtract 2, bring it on down and bring it on back. How many times can 6 go into 22? Well, let's see. 4 times would be 24. That's too high. So let's do 3 times, which is 18. Find that difference there, which is 4. Bring down that 5. And then 6 goes into 45 7 times, that gives us 42. And then our remainder is 3. So what does that mean? Well, this is saying that we're looking for the number of races, right? So 137 races with a remainder of 3 kids. That means we're going to have 3 kids not participate, right? That's too bad. Maybe they could get like a couple other kids to, you know, double up or something. Well, I mean, it's their carnival. They can decide what to do. So 825 divided by 6 equals 137 races, or I should say remainder 3 races. So there were 137 races. Okay. Hopefully those other 3 kids have something fun to do. Number 5. And 5 and 6, if you're feeling good, go ahead and do number 5 and 6 on your own. At the raffle booth, 364 4th graders each bought 1 ticket to win a new school supply set. Only 8 5th graders each bought a ticket. How many students bought a raffle ticket altogether? So 364 4th graders, okay, and 8 5th graders. How many altogether? What kind of equation do you think we need to do for this one? Well, it's one partner and another partner finding what it is altogether, right? So we're going to do 364 plus 8, and that'll give us S for students. So let's go ahead and do that real quick. $372, right? So S equals 372 students. Number 6. Here we go. Altogether, 1,263 students were enrolled in the 1st through 5th grades at Jackson School. On the day of the carnival, 9 students were absent. How many students could have participated in the carnival activities? So we know the total number of kids who go to the school, and we know the total number of kids who weren't there that day. How do we find the number of kids who were there that day and who could have participated? Well, you take your total, and you remove the kids who couldn't participate because they're not there, and you find the difference, right? So 3 minus 9 is not going to work, so we have to ungroup. Then we'll leave 5 of those 10s there. Now we have 13 take away 9, which is 4. And then 5 times minus nothing, 200s and 1,000. So all we did was we took our total, which was 1,263, and we subtracted that 9. We didn't have to divide or anything. And that equals S, and then we'll say S equals 1,254. Now you'll notice there have been a couple simple subtraction and addition equations in here, and I think that's because sometimes when kids are doing a ton of division or a ton of multiplication, they start to view everything as like, oh, I just need to like take the big number, divide it by the little number. But really, for each problem, you have to think about it, right? Okay, let's go ahead and look at the back. If you're feeling up to it, you can go ahead and try. This is about Pine Street's School Olympic Games. If you want to try it on your own, you're welcome to, but I'm here if you want to go through it with me. Okay, number 7. At the start of the games, 193 4th graders sign up to play in 3 events. 3 events. 87, see they're putting some word form numbers in there for us too, played in the first event. The rest of the students were evenly divided. Now this is, oh, I should point out, this is multi-step word problems here. So we're gonna have more than one step here. Between the second and the third. How many students played in the third event? So what we did was we had 193 kids, right? And there's 3 events. We're not dividing the 193 by 3. First, what we're doing is we're subtracting 87 because they're going in the first event, right? Okay, and then whatever this answer is, we are going to evenly divide it because that's the remaining kids for the second and third event into 2 groups. Okay, so the way you write out this in a math equation is 193 minus 87. Put that in parentheses so everyone knows to do that first, and then divided by 2, and that equals students. And then we'll put students equals whatever it is. Let's go ahead and do it now. 3 minus 7 is not going to work, so we have to ungroup. We'll leave 8 of those 10s over there, and now we have 13 take away 7, which is 6. Good. 8 minus 8 is 0, and 100 minus nothing is 100. So now we're taking this 106 and dividing it by 2, right, into 2 equal groups. So we're taking our 106, put our 2 over here. All right, 2 goes into 1 no times, 2 goes into 10 5 times, and you get 10, and you multiply that, bring it on down, bring it on back. 2 goes into 6 3 times, and you get 6, and there's no remainder. So now, in the third event, that's what the question is, we have 53 kids in that third event. Okay. Very nice. Here we go. 3 teams stacked paper cups into pyramids. 3 teams. Each team had 176 cups to use. Team 1 used exactly half of their cups. No, this one's tricky. Team 2 used 4 times as many as Team 3. Team 3 used 32 cups. So when I get a question like this, I write Team 1, and we know it's half of 176. So it's 176 divided by 2, right? Team 2, they use 4 times as many as Team 3. So then we'll put Team 3 times 4. And then Team 3 equals 32. Now they're asking us which team stacked the most cups. So we have to figure out how many Team 1 did and how many Team 2 did. And we already know how many Team 3 did, and because Team 2 did 4 times as many as Team 3, that has to be, like, they're kind of eliminated as, like, how many used the most cups. But we'll compare these two after we, figure it out. So let's start with 176 divided by 2. So 2 goes into 1, 0 times, 2 goes into 17, 8 times, and you get 16, right? Then you have 1 left over, and you get another, oh, look at that, another 16, so another 8, right? Okay, so then Team 1 used 88. Okay, now what we're going to do is we're going to take Team 2. So we know that they had Team 3's amount, which is 32. 4 times, so times 4. So 4 times 2 is 8. 4 times 30 is 120. Wow, good for them. So 128. Okay. So 128. That's kind of hard to see, right? But that's okay. So what we did was we did 176 divided by 2. And then we compared that to 32 times 4. And then we got 176 divided by 2, which is 88. And then 32 divided by, or 32 times 4 was 128. And so once we did that, then we can compare. This one is greater. So team 2 used the most. All right. A little bit tricky. I'm going to change my pen color to something darker. The Parents Club provided 357 celery sticks, 676 carrot sticks, and 488 apple slices. If each student was given 3 snack pieces, how many students got a snack? I see what we're going to do here. Do you see it? So we're going to group all of our snacks together to get a total number of snacks. And then we're going to divide the total number of snacks by 3 so that we know how many kids got snacks. Okay, so to write that out for you, it's 357 plus 676 plus 488. We're going to find this total, and then we're going to divide it by 3. So the way that you write that out to make a single math equation would look like this. Actually, I was going to use my purple. So you have in parentheses, so we all know to do it first, 357 plus 676 plus 488, close parentheses, divided by 3 equals S for student. Okay, so let's go ahead and do it. All right, and sometimes kids get nervous when it's like a triple addition thing like this. If you hate it, that's fine. You can just like do this part first and then add that total to that, or you could just, give it a shot. All right, so 7 plus 6 is 13, plus 8 more, that gives us 21, right? Then 2 tens plus 5 tens is 7 tens, right? So then we have, 7 plus another 7, that's 14, plus 6. Plus 8. 14 plus 8 is 22. And then 2 plus 3 is 500 plus, this is 6 and 4 makes 10. So it's 1,500 or 1,500, right? So now we have 1,521 divided by 3. Put that in there. 3 out here, 1,521. 3 goes into 1, not really. 3 goes into 15 5 times, right? 3 times 5 is 15. How nice. 0. Bring that 2 on down. 3 doesn't really go into 2. So 3 times 0 is 0. Bring that 2 down. Bring that 1 down. 3 goes into 21 7 times, and it is 21. And there is no remainder, which is great. Okay, so we're going to write this out. So this went into 1,521 divided by 3. So what we've done is we simplified that, right? Doing that first step and then divided by 3. And that equaled 507 students. Okay. We are on a roll. Number 10. 75 first graders and 84 second graders skipped around the gym. After a while, only 8 students were still skipping. How many students had stopped skipping? So what do you think we're going to do here? We have our 2 groups. We're going to put them together, and then we're going to remove the kids that are still skipping, and that'll leave us with the kids that had stopped. So that'll be 75 plus 84 in parentheses, and then minus 8 equals students. Let's go ahead and do that. 75 plus 84. 5 plus 4 is 9, and 70 plus 80 is 150, so 159. And then we take 159 and we subtract 8, and we get 151. So it's 151. Alrighty, 2 more. If you're feeling up to it, you can go ahead and try them yourself, or you can stay with me. 11, a team from each school Oh, we're talking about the Jackson kids versus the Pine kids. Okay, that's interesting. A team from each school had 250 foam balls and a bucket. The Jackson team dunked 6 fewer balls than the Pine Street team. The Pine Street team dunked all but 8 of their balls. How many did the 2 teams dunk in all? Ooh, okay. So let's write out what we know. We know that the Jackson team is equal to whatever the Pine Street team was minus 6, right? Because they had 6 fewer balls than the Pine Street team. The Pine Street team did all, which is 250, but 8. So minus 8. Then we're going to take our J and our P and we're going to add them together to figure out how many balls in all. Whew! Okay, so here's how we're going to write that out as a simple equation. We're going to do, so first we're going to have we'll do the Jackson team first. Okay, so 250 minus 8, which is what P is. We're plugging this in. We're bringing that there. Minus 6. So this number is what Jackson did. And then plus 250 minus 8. Ooh, look at that. So we're going to first figure out 250 minus 8 minus 6. Then we're going to add that to 250 minus 8. Okay, let's do it. So 250 minus 8. Ungroup, leave 4 tens. Now we have 10 over here. 10 minus 8 is 2. 4 minus nothing, 2 minus nothing. So P equals 242. Right? That's what this simplified down into. Now we're going to take this 242 and we're going to subtract 6 from it so that we can figure out how many Jackson was. The 242, so we can't do that. So we're going to ungroup, leave 3 tens there. Now we have 12 in the ones place. 12 minus 6 is 6. And 3 minus nothing is 3. And 2 minus nothing, 2. So now we know that this P amount is 236. And this amount here was 242. Now we're not done yet because the question is asking how many in all. So now we're going to take both of these amounts and add them together, right? So let's go ahead and do that. 242 plus 236. 2 plus 6 is 8, and 40 plus 30 is 70, and 200 plus 200 is 400. So 478 all together. So we'll write that down. This part here was 236, and we added that to 242, and it equaled 478 balls. All right. Oof. Good job on that one. Number 12. When the day was over, everybody had earned at least 1 medal, and 32 students each got 2 medals. In all, 194 each of gold, silver, and bronze medals were given out. How many students played in the games? Okay, so for this one, we know that 194 medals were passed out. So that is the total number of medals that were passed out, and 32 students got 2 medals. So we need to figure out, okay. Everybody got 1, and 32 students got 2. So we just don't want to double count those students, right? Even though they're in this 194 twice, we got to just remove that second round of them. So we'll have 194 times 3. And that equals 12, and then 3 times 270, and 300. So 582. Oh, for a second I was like, wait, why am I doing 3? It's because each of gold, silver, and bronze medals. I almost missed that each. So there's 582 medals in all. Okay, that was like, wait, where did I get that 3 from? Okay, there it is. All right, so 582 medals in all. That would be the number of, if everyone only got 1, but some kids got 2. So we're going to subtract 32 so we can remove that second batch of medals. So 582 minus 32, 2 minus 2 is 0, 80 minus 30 is 50, and 500 minus nothing is 500. So that gives us, and we'll write that out as an equation, 194 times 3 minus 32 equals 550 students. Alrighty, my friends. Go see if you have an assignment, and I will catch you next time. Thanks for joining me. Bye-bye.